back to Bytes of Pi. Today is part 3 of classes in depth, interfaces. We're going to be covering interfaces and out-of-the-box Java interfaces. The first section we'll be talking about creating, implementing interfaces, assigning to interface variables, using interface variables, and constants in interfaces. First, what is an interface? An interface is a contract with a program stating a class will implement these functions, a set of tasks. So here you notice that we have an interface called vehicle. It's essentially a collection of abstract methods. So here all it is just a whole bunch of method headers. An abstract method is just a method header without the body. So here you can see I have public, void, travel, and I have the output, the input, and the name. But there's a couple things you notice. There's the keyword abstract and a semicolon. Now, because an interface is just abstract methods, we don't need this keyword. So you can also declare the whole function without saying the word abstract, and it'll know what to do. But that's essential. We're going to need to remember that the keyword abstract for later chapters when we talk about abstract classes. But for the time being, these are abstract functions, and the abstract is just known. Now, a couple things you need to remember is that whenever you create a class, you have public class name. When you want to create an interface, you just say public interface name. So here the keyword interface defines an interface. And also notice at the end of the function, usually we have an open and closed curly brace and we have a body. An abstract method has no body. I mean, it has no implementation. It doesn't do anything. So at the end of every abstract function, you need a semicolon here. A class implements an interface by stating it in the class header using the keyword implements, and by implementing each abstract method defined in the interface. So what do I mean by that? So here I have, using our car example, I have the interface here that we declared earlier. And here I have a car and it implements vehicle. So here I am implementing a vehicle. Now because I've told the program that I'm writing a contract with the program that I'm going to have to implement both of these functions as a vehicle. So here I see that I have to implement travel in distance. So here you can see I've created this function. It has the same input and output. So the output void, the return value is void. The name is the same, exactly, the casing matters, and the input values are the same. So I'm only inputting one variable here in distance, and I'm implementing it right here. I'm actually putting some meat on the bones. So while the interface is a contract saying I'm going to have a function that will do something, here I'm actually doing the thing. I'm actually going to, every time I call travel, I'm going to be adding miles. So I have this variable int miles, and every time I call travel and add miles to it, it's going to put miles on my car. Now I also have to implement get distance moved. So here I am returning how much I've moved so far, how much I've traveled, and I'm going to return the value miles. So now this is fully implemented. I'm implementing vehicle. Now if I had left one of these functions off, if I chose to do travel but not moved, it will not compile because it says you've made a contract. You need to implement, put some meat on the bones of both of these functions. Now, a class can implement multiple interfaces. This is kind of when you getting a little more advanced. So I've created here's my vehicle interface. I've created another interface called get heavy object, which will be get tons. So I want a car is a heavy object, and so is a building. I want to be able to have every heavy object to return get tons. So here, if I want to implement both interfaces, I have to say implements vehicle. And I have to implement travel again and get distance moved. And notice I have a comma and then the next interface, heavy object. And since I'm implementing heavy object, I also have to implement get tons. So here I can keep chaining multiple interfaces on it as long as I keep implementing the functions that the interface declares. Assigning the variables. This is where you probably want to make sure that you rewind the video because this is really key. You will be tested on this type of these key things about interfaces. The first thing is you can create variables for interfaces. However, you can't create an instance of an interface. So if I have this, so here I have a vehicle, interface vehicle, I can't say new vehicle because there's nothing to it. There's no meat on the bones. So the compiler will complain and say, nope, you cannot create a new vehicle. However, you can see that car implements vehicle, right? So a car, if we want to talk about relationships, a car is a vehicle. It's an is a relationship. So I can do this. I can create a vehicle B and give it a new car. So even though I'm creating a new car, I can say a vehicle B is a new car. Now if I had other vehicles like an airplane or a boat, I could also say vehicle B equals new boat or vehicle B equals new airplane, because a car is a vehicle. Now the opposite's not always true. A vehicle can be anything. It could also be a boat or an airplane. But in this case, I'm going to assign it to car. So I can call the functions as a variable b. I can call the vehicle functions travel and get distance moved. So you can see in the program I can still call that. Now for the interface variables, you can only use define interface methods, and this is key because this will be on the exam. At least one question like this will be on the exam, or at least in the tests that we have here, because it'll define what you know about interfaces. So if I do what I said before, I'm going to create a new vehicle and call it car. I can call travel and get distance moved because they're defined here. However, here you notice when in my implementation, car implements vehicle, I also have this function honk. Now honk is not part of the vehicle interface. So even if I am adding a new car and calling and setting it to vehicle B, I cannot call honk. Once I set it to a variable, I can only use that interface's functions. I can't use the car's function because the compiler at this point only knows that it's a vehicle. It doesn't know that it's a car. It doesn't know that it's an airplane. So at this point, your compiler will complain saying, hey, I don't know anything about this function honk because all I know about is travel and get distance moved. Even though car does have a honk function, you won't be able to use it in this variable. Interfaces can also have constants, which are variables that can't change. You can define these within the keywords using the keywords public, static, final. So here we've talked about static in the previous section. Static is something shared, so every vehicle is sharing these three variables. And this last keyword is something you may not be familiar with, the word final. Essentially what that means is you cannot change this again. This is telling the compiler, I'm setting this variable type ground to ground, and nobody can change this value again. It's stuck. So if you try in the compiler try to change this variable to something else, it will complain saying, hey, this is fine. You told me it was final. I can't change it anymore. Now you can use this in regular classes as well, but these are things that are allowed in interfaces as well. So I can declare abstract functions, abstract methods, and I can also declare constants. Now here are two out-of-the-box interfaces in Java, the Java Lang comparable and the java.util.List interface. The comparable interface has one key method that you need to be concerned with, and that's the compare to function. Now this T is a placeholder, is using generics. So essentially when I'm going to compare something, I want to compare it against other cars. So I'm not going to compare this against apples or bananas or airplanes. This car is going to compare against other cars. And that defines what's here in this parameter. You don't need to know the specifics about generics, other than if I want to create this compare to again for other cars, I have to specify that in my generic tag here. Now what does compare to do? It does three things. It's kind of like this. If you remember what we did in the previous unit, we talked about overriding the equals function, where I'm comparing against another instance of that type. Well, here this is very similar to equals, but it does a little more than that. It'll return, if I'm comparing two objects and I'm trying to sort two objects, I have to define what makes one object greater than or less than another. It'll return less than 0, or a negative number, if the object is less than other. So if I have a car and I'm passing it another car, if this car is less than the other car, it's going to return a negative number. If the car is equal to another car, it'll return 0. And if this car is greater than another car, it'll return a greater than number. So it'll return 0 if they're equal, and it'll return something greater than 0 if the object is greater than other. Now, how can you say one car is greater than another car? You have to come up with that algorithm. In this case, I'm going to use an integer weight. So I'm going to say one car is greater than the other car if the car weighs more than the other. So if one car is 3 tons, the other car is 2 tons, then I'll call the 3-ton one greater than the other one. So using that, I'm going to use this variable. Now, I can do all of this in one fancy statement. Return weight minus other weight. So if this weight is greater than the other weight, it'll return a greater than. So let's take it through the 3 scenarios. So if this is 3, well, actually let's do the less than. If this is 2 and the other is 3, 2 minus 3 is -1. So it'll say this other car is bigger than this car. It's going to return a negative number saying that this car is less than the other car. If they both are 2 tons, it'll subtract 2 from 2 and make it 0, so they are equal in weight. And then if it's greater than another one, say this is 3 and this is 2, if this car is bigger than the other car, it'll return a positive number. 3 minus 2 is 1, so it'll be a positive number, and it'll fit this compare to. Now, one of the cool things is that one of the string that you've been using since the beginning of class, already implements the comparable interface. So not only does it have equals, but it also has compare to. And the way it compares is this. It essentially checks, like you would think in alphabetical. It'll check the first character and compare those two. If they are the same, it'll check the next 2 characters and see if they're the same. It'll check the byte value. So if you remember from like an ASCII chart, A comes before B. So in this case, when I call an apple compared to banana, it's going to return less than because A is smaller than B. So when you go to the system output, it'll say apple comes before banana because A is smaller than B. Now, if they both had A's, like apple and aardvark, it would compare the next 2 characters. The last thing we'll talk about is the list interface. A list is an ordered collection of objects. Now, we are not going. The 2 things that you need to be aware of with the list interface is size. It returns how many objects are in that list, and also add. So when again, we're using the generic, and this is going to be a list of cars. It's not a list of bananas or airplanes. This is a list of cars. So I can create a new list, add new cars, and then iterate through the list. And this is a special for loop that we'll get into later. Again, we won't get into the details for this one, and our labs won't cover this, but this is kind of an introduction to our next chapter where we're going to talk about arrays and lists. So again, we'll talk about this in Unit 6. This concludes Part 3 of Classes in Depth. Thanks for watching.